Bismillahirrahmanirrahim. Mrs. Sobia Suhail is here. In my previous two videos, I have explained the law of indices, part 1 and part 2. This is the part 3, and again, I will just revise the law of indices, which I have explained already. So, just revise one more time that if two numbers are same and two same bases are multiplying with the different powers, so their powers will be added up. Okay, now if the two numbers are dividing with the different exponents, so the exponents will be subtracted. And if a number already have an exponent and we are taking another exponent to it, so previous exponent and new exponent will multiply together like this. If two different numbers are multiplying and they are taken to one exponent, so whether you can, if they are normal number, you can multiply them. Okay, then take the power on both. Or if they are different numbers with different variable, so distribute this exponent to both first number and second number, and it will be a exponent n multiply by b exponent n. Means when you are opening the bracket, exponent will be given to both and the relation between them will remain same. Like if two numbers are dividing and you are taking an exponent on that, so opening the bracket means first number exponent divided by the second number exponent. And if any number is there is taken to a power of 0 or raised to a power 0, so that number will change to 1. So these are the 6 different laws, and they are equally helpful in grade 6 students, 7 students, and grade 8 students, and 9 also, 8 and 9, and for the IGCSE classes also, Cambridge classes. So this my complete topic will be equally helpful for all these students for understanding the laws of indices or exponential laws. Okay, next I want to explain about the number with the rational exponent. If the exponent is rational, so how to solve these type of questions? But first we have to understand, first I just want to revise again the exponent. If n is any positive integers, so a power n is defined as that number which is being multiplied by itself n times. Like a is multiplying to by itself how many times? 1, 2, 3. So it's a power 3 or a exponent 3. This is the exponent and it is an integer. Okay, so if the power is a rational number, what is the rational number? All the numbers which are written in the form of p by q, where q should not be equal to 0. We know that the rational number definition. If the power, suppose a is n is equal to b, we are saying that this number is equal to one single number, that is b. So b is equal to a power n, means a is multiplying to itself times. So how a can be defined in terms of b? So a can be defined as like this one. Before that, take 1 by n power on both sides. Here n and 1 by n cancel. Now a is equal to nth root of b. We call it as 1 by n as nth power of b or nth root of b. So here a is called nth root of b. Here a is called nth root of b. Next, I would like to explain a few more points about this topic. A radical expression. What is the radical expression? An expression that uses a root, such as square root, cube root, are known as radical expression. Square root is written by 2. This is square root. Cube root is written as in the power as 1 by 3, or this is the cube root. Okay, so all the expressions that involve these signs, symbols, or roots, they are the radical notations. Therefore, the number this one. Let's take this number 3 exponent 3 by 2. How to solve it? Separate this 3 power and separate this 1 by 2 number. Okay. After that, 3 by 2, 3 by 3 power 3 remain as it. 1 by 2 is like square root in the symbolic form, and then square root of 3 power 3 means 3 is multiplying to itself 3 times. So 3 3s are 9, 9 3s are 27. So we'll write it as 27 square root or square root of 27. Done. Next is I just few more example, like what it is written as. This is the cube root of 25, or the radical is of order 3. Okay. Fifth root of 125, or radical is order 5. Square root of 32, or the radical is of order 2. Now I will write a few examples for express the following numbers in radical form of order 3. Suppose 4 is a number. You have to express 4 in form of order, radical form of order 3. Write down 4, write down 3 and 1 by 3. Write down, okay, because 3 can cancel out, so we can make 3 in the exponent multiply and divide by 3. 4 power can be separated and this exponent can be separated. After doing this, we can do 4 power 3 means is multiplying to itself 3 times, and can be mentioned as cube root of that. Now internal number we solve, like cube root of what is this number? 4 4s are 16, 16 4s are 64. 4 is equals to root of 64, cube root of 64, and is now in the radical form of order 3. If the number is, we have to write in the radical form of 5. So let me write on the other page. X 4 as a radical form of order 5. So 4 here, write down its exponent 5 and fifth root. Fifth form here and fifth root as here shortly. Okay. So now fifth root of 4 5 means 4 multiplying to itself time. That is 1024. If we need to express like 7 as in radical form of order 6. Okay, so 7 radical form of order 6 means take exponent 6 and then 6th root, exponent on the number, and 6th root express like this. Okay, now 6th root of 7 power you solve by calculator. So 7 and this is showing the exponent 6. This is equals to 117,649. This is number 7 expressed as radical form of order 6. In this way, you can transform or express any number in the radical form of any order. Okay. Now I will just solve two examples. Simplification of simplify Some of the parts I solve with the square root, some of the parts I solve with the cube root, and so on. Fourth root, fifth root, this one. Okay, let's take one example for 8 square root. Okay, you take the factor of 8 to take the prime factors. 2 times 4, 4s are 8. 2 1 2 times 6 are 12, 2 3s are 6, and 3 1s are 3. And 48 we factorize like this. This means in the exponent there is a square root. Square root means make the parts as many as it is possible for you. This will be written as 2 square. This will be written as 2 square, and this is the last single number 3, and all have square root of it. Okay, using the exponential laws, if the power is given to all numbers, so when you open the bracket, this exponent will be given to all the terms inside the bracket. Like the first term will have this power, second term will also have this power, and third term will also have this power. This is the second root for square. So square root cancel 2. This will also be cancelled, so 2, and this root is not with any power of 3, so it will remain as it is, like square root. 3 will stay under the square root. So 2 2s are 4. You can like 3. So completely solve. It cannot be solved. Okay. Next question I will write root of 220. To factorize the number as an even number 0, so I can try with 2 also. 2 1 times 2, 2 times 4, 1 left, 10, 5s are 10. It's not even number now. I cannot start 2, but it has 5, so I can start with 5 also. 5 2s are 10, 25 5s are 25, 5 5s are 25, 5 1s are 5. So 250 I factorize over here. Cube root, I will make the set of 3 numbers from here. Set of 3 numbers. This is separate. This set of numbers means 5 3. This can be written as 5 power. And whole power is 1. Opening the brackets, I will take the root here, and then I will take the root on the second also. It cannot be further, so it can be written as it is. This is so it is 5. It's better if we write this in the like 5 and cube root of 2. Write the root number very small as compared to the number which is written by it. Okay. So in this method, we can, if this method in which we can solve all the numbers with the square root. This is the method I explained in which you can solve all the terms given and taken the power of cube root on. Okay. We'll start one more example with 5th root and 7th root. Okay. Okay. I'll take a number 26 into a root. Factorize 96 is it's an even number, so we can try with even number. 2 4s are 8, 1 left 16, 2 8s are 16, 2 2s are 4, 4s are 8, 2 1 2, 2s are 4, 2 6 are 12, 2 3 are 6, 3 1 are 3. All the factors are here. So 96 factorize this one. As there is a 5th power, so we'll try to make a set of 5 numbers. Here it is possible, so I make a set of 5 numbers. 2 power 5 and 3 will remain separate. All are taken this one 5th root. Open the bracket and 5th root will be given first term and second in both. 2 power 5, 1 by 5 and 3 power 1 by 5. So 2, its 5th power is with the 5th root, 2 will separate, 3 will with the 5th. And this question is, a question like this solve like. Let me take one another example. 768. There is a 7th root. I'm taking the example count down 8. So it's equally like you can apply the same for solving any question, any example. Count down 7 I told you, it's helpful for grade 7, 8, 9 and so you can try laws for solving the question in any grade. The law is the same. It's even number, so I will try with 2. 2 3s are 6, 1 left. 2 8s are 16, 4s are 8. 2 1 2 1 left, 9s are 18, 2 2s are 4. 2 9s are 18, 1 left, 2 6 are 12. 9 6. I think the factors will be repeating after that. When you will start the factoring, you will feel that it's and you make factor so easily. 1 2 6 are 12, 2 3s are 6, 3 1s are 3. Okay. Now seventh power means the set of 7 terms. 1 2 3 4 5 6 7 till here. Okay. So you can make till here. This one separate 2 7. This 2 only single. This 3 also only single. External exponent is 1 by 7. So give this external exponent to all the terms inside. 2 power 7 to 1 by 7. 2 power 1 by 7. 3 power by 7. It's 7 and 7 cancel. Means this is from any root. Free number. Both will stay inside. We can apply exponential laws that the power is same. They can be kept same in the same power. Or they can be written as 2 3 6 with root and 6 in the 7th root. Please, the difference between these numbers and the root always is written in a very small hand up on this one corner and normal number. So 2 outside, 6 is staying inside because this 2 and 3 are not becoming free from the root. So 2 3 is 6, they will stay inside the 7th root. Only this 2 is becoming free from the root after making the factorization of the number. Like this, you can make any number factorize and solve root whatever the root is given, whether it is a square root, a cube root, or a 5th root, 4th root, 6th root, any root. Okay. Thank you so much. I would like to revise on a faster pace all the material which we have solved in this one video. So I just explained the law in this videos. Once again, law. And this is I explained these laws. When two numbers are multiplying same number, you can add. When they are dividing, you can subtract the exponent. Power to power, both exponent will multiply. Two number exponent, give them to both. They are multiplying or dividing. If the exponent is 0, that will become 1. After that, I have explained you about the rational exponents. If it is a positive integer, it's multiplying by it to n times. It's written like this. Okay. If we suppose that this number is equal to b, so how b is expressed as a, how can be defined as nth root on both sides and nth cancel, will stay nth root. Now b is equal to a multiplying by itself n times, but a is equal to b with nth root of b is equal to nth root of b. After that, I have explained radical expression, that expression that use the root, such as square root, cube root. They all are called the all are known as the radical notations, and they are called the radical expression. Okay, like in this form. So this is the cube root of 25. This is root of 125. This is square root of 32. Then I express the number in the radical form given order. If radical form you have to express, make that radical number with the same exponent. Keep the exponent with the number, write down the radical form for the given order. If order 3, write like this. If order 5, so 5th root and 5th exponent. Keep the exponent to the number root, express like this. X7 as the radical form of order 6. Order 6, so take 6 in the power and 6th root. The 6th power to the number, write the root as you can in this way, you can express in this. that, I solve a few questions related to radical expressions. How to simplify the square root? I solve after doing factorization, taking a pair of two numbers. It's cube root. I solve after factorization, making the set of three numbers, and I solve a question with the fifth root. So I make factorization, then take a set of five numbers, I simplify. Then I take a number with seventh root, I tries a set of seven numbers, and then simplify in the same way. Thank you so much. Hopefully you would like my video. In the next video, I will simplify more difficult questions with all the using all the exponential laws or the rules to solve radical expressions. Thank you so much. Allah Hafiz.